Welcome to Study Loop.
Okay, so this is a quite challenging problem that requires you to know quite a lot regarding integration, and it takes a lot of algebra to go through it. So I'm going to go through the big concepts that you want to really pay attention to. I cannot go through each of the steps because that's going to take more than 20 minutes for me to explain everything, but hopefully it will help you solve this problem by yourself. It's going to be very good practice. Okay, so let's start with this expression. You see that the numerator is a cubic polynomial, the denominator is a fourth degree polynomial. So at this point already, you should start by thinking, okay, can use substitution work? Because if I do use substitution, and the denominator will produce a cubic, and it might cancel with the top. But the thing is, when I do that, 4x cubed plus 8x, it doesn't really seem to appear on the numerator, so that doesn't work. So the next thing you might want to consider is, of course, it's not one of the easiest things that you could do, but it is partial fraction decomposition, okay? And in this case, what makes things a little bit more complicated is the fact that the denominator is a quartic, and you end up having irreducible quadratics as their factors, which makes the decomposition a little bit tough to solve. So I'm going to go through the idea of it. Okay, so let's start with that portion first. Let's consider the decomposition. So in the decomposition step, what you're going to basically say is, let me call this portion delta. First, you're going to factor delta. You will end up having, if you notice that this is a special form of a quadratic, it is a squared plus 4a plus 3. So you can factor that quite straightforwardly, calling it x squared plus 1 times x squared plus 3. So here, you see that x squared plus 1 and x squared plus 3 are not reducible by linear factors anymore. So these are called the irreducible quadratics, okay? So what that means is when I do a partial fraction decomposition, this is what it's going to look like. X squared plus 1, the numerator is going to be a linear expression, ax plus b. And the other part, x squared plus 3, you will have another linear expression. So you have to solve A, B, C, and D. It's going to be a system of equations with 4 variables, which takes a very long time to solve by hand. So it's one of the reasons why this problem could be a little bit tough, okay? Because the longer time that you spend doing algebra, the more likely that you make a small mistake, which you cannot really catch until you check the answers at the end. So makes it a tough one. Anyhow, using this, basically what you're going to say is this is equal to x cubed minus 2x squared plus 2x minus 5, basically the numerator of the integrand. The denominator, I'm just going to write delta. What you're going to do is to multiply delta on both sides. So you will get x cubed plus 3 times ax plus b x squared plus 1 times cx plus d, and the numerator part, let's call it square. That ends up being the numerator. Okay? Now, there are two paths that most people take whenever they do partial fractions. One type of people will actually expand the left side, simplify it, and then they compare the the coefficient of each of the terms that you have on the left and the right. So for example, on the left side, you will have a, oh, that should not be a cube, that should be a square. Excuse me. You will notice that ax cubed and cx cubed shows up. So a plus c has to be 1. You can also see that 3b and d has to be a -5 because those are the constant terms. So just like that, you might be able to calculate the coefficients, compare them, and you end up having a system of equations. That's one path. Another path that I usually like to take is to start from the equation that you have right here and start plugging in numbers. That usually works extremely well when you have a linear factor instead of a quadratic. Because if you have linear factors, by plugging in the number that you see right next to the variable or the opposite of it, you can actually make it equal to 0, simplifying the expression significantly. So in this case, it's a quadratic, so it's a little bit tougher, but I will demonstrate how I did it. So you can always start with easy numbers like x equals to 0. So when you plug in x equals to 0, you can see that the first term is 3 and a b. And the next term you will get 1 times d. So 3b plus d is the left term. On the right side, you see that the first 3 terms has a 0 in it. So you will only get a -5. So that's an expression that you're going to get. I'm not going to go through the precise calculations, but I did x equals to 1, x equals to -1, x equals to 2 as well. And then I get a system of equation that looks like this. 4a plus 4b plus 2c plus 2d equals to -4. The next term is -4a plus 4b minus 2c plus 2d, -10. And the last one is 14a plus 7b plus 10c plus 5d equals to -1. Okay, now what's nice, if you can see here, is that the second and the third equation, you can see that the a's and the c's can cancel each other while b and d will remain. So by using that fact, the first equation and the last two equations is just going to be a system of equations of b's and d's. So you can figure out what b and d are right away, which makes the calculation just a little bit easier. Okay, and of course you would still have to use the fourth equation, which is kind of ugly, but you will end up having, I already wrote it down, a is 1/2 as well as c. B is -3/2, and D is -1/2. Okay, now this took me about 10 minutes just to solve these values. So again, I'm not gonna have enough time to go through it in detail, but that's the big idea of what actually is going on. Okay, so let me move this aside. So we're done with this part. So what does that entail? Well, I was originally trying to solve it in this form, so let's figure out what this expression ends up being. Through this process, I was able to break this down into, hold on, let me get my notes. Found it. It is going to look like the integration of 1 over 2 x over x squared plus 1 minus 3 over 2 1 over x squared plus 1 plus 1 half x over x cubed plus 3, x squared plus 3, minus 1 half 1 over x squared plus 3 dx. Okay, so it looks longer, but each of these integrations are doable. Okay, it's not easy, but it's doable. So another big picture that we need to see here. Two things are going to happen. Hopefully you are familiar with some of these expressions, like this one. If you instantly remember that this is a tangent inverse, that's going to be a huge advantage of you, okay? A similar thing happens with this one, but not even I memorize these kind of formula all the time. It's actually something that I had to derive by myself. And if you look at the beginning of the formula sheet in calculus books, you usually can find it there, but it's very unlikely that most people have memorized that. So I will actually go through how to calculate this integral, and I would assume that you would also be able to do it for this one, but it's more likely that you actually memorized it, okay? Now, these two can be solved exactly the same way. It's just a straightforward U substitution. So I will go through one of them just to demonstrate how you would do it. Okay. All right. So let's start with the easy one, the red one, the U substitution. This portion, if I let U equals to x squared plus 1, I know that du equals to 2x dx. So x dx is du over 2. Okay, now if I substitute that in, the integration of x over x squared plus 1, I'm going to write the dx on the top just to make it look a little bit easy to follow. This portion is du divided by 2. This portion is u. So by substitution, I was able to get 1 half integration of du over u, or 1 over u du if you prefer that notation, but we all know that this is just a natural log of absolute value of u. And u is equal to x squared plus 1. So what's nice here is that we actually don't need the absolute value because x squared plus 1 is always positive. So you can rewrite it as the natural log of x squared plus 1 in parentheses. You don't have to call it absolute value, okay? And of course, we have a plus c because this is an indefinite integral, but I will omit it for just for simplification purpose. All right, moving on. You do the same thing with this expression, so I'm not going to go through that much in detail. Next, let me move this. Okay. Now, this one, the steps that I am going to take with the other one will actually show you why the antiderivative of this will be a tangent inverse. And you basically use trig substitution to do so. And hopefully you're going to be able to follow it because it is quite intense. Okay, so let's take a look at the integration of 1 over x squared plus 3. Now, when you learn trig substitution, you kind of learn the trick that trigonometry starts out as a study of right triangles and similar triangles. So things that are related with squares usually go very well with trigonometry. Another fact that you could remember is that sine squared plus cosine squared equals to 1. Tangent squared plus 1 is equal to secant squared, etc. So the Pythagorean identity of the trigonometric expressions are also quite useful too. So that's basically the idea that we're going to use. So here, the first step that we can take is to factor out a 3 and make it look like this. This is x divided by root 3 squared, because if I take out a 3 and if I pull out a square out of it, it'll be a square root. Okay, and I pulled out a 3 from 3, so that's just a 1. So it looks like something squared plus 1. So if that something is a tangent, tangent squared plus 1 is secant squared, which makes it a little bit easier to deal with, and something really nice is going to happen next. So that's why this technique is awesome. And then we will do the trig substitution. Tangent theta is equal to x over root 3. So if we do tangent squared plus 1, the denominator becomes secant squared. Now, this is the part that's amazing. If I take the derivative with respect to x on both sides, it turns out, what's the derivative of tangent? It's secant squared. So you will get secant squared theta is dx over root 3. So root 3 secant squared is what dx is equal to. Okay, so when I do the trig substitution, I'm going to be able to see that the denominator is secant squared. Dx also has a secant squared, so they cancel each other out. So this expression makes the integral look like root 3 over 3, the integration of 1 d theta. Much, much easier to deal with. So this is, of course, root 3 over 3 theta. So my last step is, well, what's theta in terms of x? We already have this expression. From here, we can deduce that tangent of an angle is x divided by root 3. So that angle must be arctangent of x over 3. So root 3 over 3. I don't have space, I'm just going to say tangent inverse of theta. Okay? Or x over 3, not theta. There you go. So the general form, I think it has a in it, where that's the square root of a and stuff. I cannot remember exactly what it was, but this is basically the step you take in order to prove what it looks like. Okay? All right, so going through all of these steps, I believe in you. You're going to be able to solve all of these integration. Let me move these guys over here. And the rest, I am just going to write down the answer, what it would look like. So these two involves a natural log of x squared plus something. These two would involve the arctangent, okay, as the integral. And let's not forget that there's going to be a plus c at the end because this is an indefinite integral. And oh, I forgot to write down the solution, but it is going to look like, let's see if I can actually write it here. 1/2 of that, so it'll be 1/4 natural log of x squared plus 1. Let me write this one over here next because I already know what it should look like. There should be another 1/4 natural log of x squared plus 3. Using the law of logarithms, you can combine these two if you want to, just so you know, but I won't. Okay, minus 3/2, that's just tangent inverse. And the last one, it's negative 1/2 times this number. So negative √3/3. Not 3/6. See, it's such a long problem. I wasn't even 100% prepared to write the solution so smoothly. Okay, so that is going to be tangent inverse x over √3 plus c. All right, so numerically it should be fine. At least concept-wise, this is exactly what you're supposed to solve this problem. Now, good luck to you guys.